Hey everybody. So this is that question. I know you can't really see it, but it's the question with the position time graph. So starting at 10 meters, moves with constant negative velocity over 4 seconds to a position of 2 meters. And then from 4 to 8 seconds, it's standing still at 2 meters. And then from 8 to 10 seconds, it moves from 2 meters to 4 meters. So the question asks for the total displacement traveled from 0 to 10 seconds. Well, remember, displacement is defined as change in position. So just compare, displacement of anything is just comparing where something ended to where it began. It's not a really real big deal here. It ended at 4 meters. It began at 10 meters. That's a displacement of -6. How do you get from 10 to 4? How do you get from 10 meters in the beginning to 4 meters in the end? You have to change your overall position by -6, okay? -6. Another way to do it would be 10 minus 4, because you start at +10, you ended up at +4. 10 minus 4 is... 4 minus 10, excuse me, 4 minus 10, because it's always final minus initial, is -6. The easiest way is pull the numbers off the graph. You start at 10, ended up at 4. How do you get from 10 to 4? You change your position by -6. So that's the change in position. Whereas the distance, so -6, the distance is how far you would physically walk, right? If you physically walk, no sign involved here, no negative sign. You physically walk from 10 meters to 2 meters. That means you walked the distance of 8 meters overall. Then you stood still for a while. Then you walked from 2 meters to 4 meters. I mean, you had to go another 2 meters. So you went 8 meters here, and then you went another 2 meters there. So that's a total distance of what, 10 meters, right? Then I think the next question is average velocity over the 10-second interval. Average velocity is just displacement over time. So if whatever your answer is to part A, in this case it's -6, and -6 meters for displacement over 10 seconds, -6 over 10 is -0.6 meters per second. The average distance, the average speed is the total distance over time, and the total distance is 10 meters. The time is 10 seconds. So that's 10 over 10 is 1 meter per second. Let's see here. Next. We're doing great. The initial position is right up there. It started at 10 meters at 0 seconds. So that's the initial position, 10 meters. What's the position at 2 seconds? Go to 2 seconds on the time axis and go on up, and it's 6 meters. You can see that right off of your graph. So go to 2 meters on the time axis, go on up to the graph, to the line, and then going over and see what position that corresponds to, and that's 6 meters. Let's see here. I think the next one is the instantaneous velocity at 2 seconds. Yeah, so the instantaneous velocity at 2 seconds is the slope of the line. Remember the slope of the actual line segment that passes through that moment and that point. So at 2 seconds, you're going up to the line, which is at 6 meters, and you need to find the slope of the line that passes through this. Now, it's a nice straight line, and so I would use the slope of the entire line going from here to here. The slope of that entire line is a change of -6 meters over a time of 4 seconds, right? -8 meters, sorry, 10 to 2. 10 to 2 is -8 meters over 4 seconds. -8 over 4 is what, -2 meters per second. So the slope of this line is -2. This line segment right here, 10 to 2 is -8 meters over 4 seconds is -2 meters per second. So that's the instantaneous velocity at 2 seconds. It would also be the instantaneous velocity at 3 seconds and at 1 second. And lastly, what's the last question? I think it is, okay, the mathematical model. I know that throws a lot of people for a loop. The mathematical model from 0 of the motion just from 0 to 4 seconds. So the mathematical model representing just that segment from here to here. That's the equation that represents that line. More importantly, it's an equation that models that motion. And it's an equation that models, in this case, the motion of constant velocity. Okay, so this is just an equation that says that the position is equal to the slope here, which is the velocity of -2 meters per second. So that's remember that whole thing represents the slope. It's the constant velocity times, so that's that slope, times your x variable, which is on the time axis, right, times t, plus the initial position, which is plus 10 meters. So the mathematical model, you don't really need parentheses here, but the mathematical model is your y equals mx plus b. In this case, position equals constant velocity of -2 meters per second times your time variable plus 10 meters. The thing that's way cool about that is that now you can find out where you would be at any given moment. If you wanted to go back to the previous question that says, where are you at 2 seconds? What's the position at 2 seconds? Put 2 in here. 2 times -2 meters per second is -4, plus 10 is 6 meters. So mathematically, it tells you what's the position at 6 meters? What's the position at 2 seconds? 6 meters. You can figure it out from the equation. You could also, of course, figure it out from the graph. That's what we did earlier. Well, gosh, that was fun.